Hi, my name is Michael Quirk. I'm the Executive Director and Acting Journalist of Climate Change National Forum, and welcome to the second installment of this interview series of the participating scientists of Climate Change National Forum. And today I have Dr. Andrew Dessler chatting with me. And Dr. Dessler is a professor of atmospheric sciences at Texas A&M University, and he is also the author of the book The Modern Climate Change, and has been a member of CCNF since about January. Am I coming in loud and clear, sir?
Yes, welcome from College Station.
All right. So just to recap, Dr. Dessler, in your last post to the forum, which was an adaptation of your oral and written testimony on the President's Climate Action Plan from a Senate hearing earlier this year, you stated that the climate is warming and that the recent warming is extremely likely due to emissions. And you state that based on several lines of evidence, we know the following, that the planet is going to warm, extreme heat events will become more frequent, and the distribution of rainfall will change, the seas will rise, and the oceans will become more acidic. Has anything come out recently that would make you change or alter those conclusions?
Yeah, I don't think so. I don't think anything's happened in the last 40 years that would cause anyone to question any of those conclusions. If you showed that to somebody, a climate scientist in the late 70s, early 80s, they would look at that and say, yeah, this is exactly what we expect.
And you also mentioned that the mainstream theory of man-made climate change, what you call the standard model, can explain just about everything we have observed in the climate system, and that it has made many successful predictions, which are what you call the gold standard of science. Could you share with us some of these successful predictions?
Yeah, I mean, so just for the listeners, you know, the most convincing way to show a theory is correct is to make a non-trivial prediction of something that's going to happen. You know, if you predict that X is going to occur, and it's not obvious that X is going to happen, then if X occurs, people can say, yeah, that theory that predicted that. So just as an example of the kinds of things that have been predicted by climate scientists, you know, for example, long ago, long before measurements were available, they were predicting that the Arctic would warm faster than the Antarctic. They were predicting things like the water vapor feedback, which was predicted long before it was observed. You know, there's a long list of predictions that were made. I mean, in the 70s, people were predicting about how much warming we'd get over the next few decades, and those have largely been borne out. So there have been lots of very successful predictions that have been made, and I would say that very few predictions have turned out were not borne out. There are things.
That was my follow-up question.
Oh, go ahead.
No, please continue.
I'd say there were some things that were not predicted that, in retrospect, are kind of surprising. But you know, most of the major predictions of the theory have all been validated. And I guess we'll talk about the hiatus, which I think falls into the category of sort of unpredicted but surprising occurrence.
And FYI, I'm posting up a graph right now that Dr. Shakun recently shared in the forum showing temperature anomaly from 1880 and zooming in on what you're speaking about, the hiatus with these other graphs, because that's just kind of, I guess it started in that spike right before 2000.
Yeah, I mean, right after the big El Nino of 1998. And I should say, it's useful to make a statement here about climate skeptics. Climate skeptics predict nothing. They've never made, to the best of my knowledge, a successful prediction. They weren't predicting in 1998 that the climate would stop warming. You know, climate skepticism is all this post hoc criticism. Well, yeah, you didn't get that bump or that wiggle of the temperature time series right. I mean, it's not science. You know, science is making predictions, is using all of the data to try to come up with a single theory that explains everything as closely as possible. And that's not what climate skeptics do. That's not climate skepticism. I mean, they have no theory. They make no predictions. They're not really doing science. It's just this criticism that people use to advance particular political agendas. I mean, what we do is actual science. You know, we have theories, we test theories, we make predictions, we see where they occur, where they don't occur. And when we miss prediction, we go back and we enhance the theory. I mean, that is science. you listen to climate skeptics, if you make a prediction that's wrong, well, that completely invalidates your entire theory. And that's not, again, that's not how science works. I mean, these people are not doing science. You know, the hiatus, well, let's talk about the hiatus. So you can put up the figure. And, you know, the hiatus is really interesting. And I think it's something that, that is something that we don't completely understand. It is not the case, as you often hear, that the climate has stopped warming. I mean, the climate is still changing in really weird ways.
And that's what I was going to ask. Just we do hear from the skeptic side of the, you know, there's been a massive increase in CO2 just, you know, with the global economy right now, and so they try to frame that as a gap in knowledge, and it sounds like it is. But just to put it in the context, looking at the other graphs that have been shared in the forum from other scientists, including Dr. Shikun in his latest piece, how do we put the hiatus in the context compared to the, you know, ocean heat content, which is rising, and also the sea level rise? Because there's no hiatus there that can be seen in the graph, correct?
Yeah, I mean, the important thing to realize is the climate is still changing. So if you look at most of the globe is still warming. There's just this slice of the Eastern Pacific that's cooling, and that cooling there is offsetting the warming. And if you look at it seasonally, except for Northern Hemisphere winter, the planet is still warming, but Northern Hemisphere winter is cooling. Now, obviously, these can't continue. You can't have spring, summer, and fall warming and the winter cooling, and you can't have the Eastern Pacific cooling and the rest of the globe warming. So this is going to stop at some point, and we're going to figure out what it is. But make no mistake, weird things are afoot in the climate system. The idea that, quote-unquote, climate change has stopped is completely bogus. I mean, if you look at the data, the climate is still shifting. It's still changing. It's just the global average surface temperature is not rising as fast as we predicted. So it's that one metric that's really cherry-picked out of all the things they could pick. And
are there any other significant gaps in knowledge or big known unknowns?
Oh yeah, there are lots of them. You know, we don't really understand how aerosols affect clouds. You know, the cloud feedback, I've done a lot of work on that for the last 5 years. That's still a reasonably big unknown. You know, I think heat going into the ocean, that's the hiatus. That's, you know, the ocean variability. There are lots of things that are unknown, but the key thing to realize is these unknowns are not existential threats to the theory. It's not like we're going to find something out about clouds that is going to cause us to conclude, well, carbon dioxide is not a threat. I mean, we're going to find out about clouds, and it's going to refine our understanding. But I think there's very little reason to think that we're suddenly going to decide carbon dioxide is not a significant warmer of the climate. Just like there are still people that do research on lung cancer. That doesn't mean they're going to discover that cigarettes don't cause cancer. I think we've established that. And we've established that carbon dioxide is a powerful greenhouse gas.
Roger, sir. And just switching over to the question of, you know, how much warming there's going to be and how fast it'll happen. Regarding the representative concentration pathways used by the IPCC to represent possible future emissions, CO2 concentrations, and temperature changes, you recently stated that the RPC 8.5 pathway can be fairly characterized as a business-as-usual scenario in that it assumes no substantial mitigation action worldwide. And for those viewers who are unfamiliar with this, the RCP 8.5 pathway puts kind of the concentration of CO2 around 1,300, and correct me if I'm wrong, sir, 1,300. Right? Am I coming in?
Yeah, you know, I have to be honest. I don't know. That sounds right for a long-term amount, but I have to be honest. I would have to look up the graph, just like you.
Don't mean to play gotcha here or anything. It's just, I mean, it's a mind-bogglingly high parts per million emissions scenario. And Dr. Nielsen Gammon said that, you know, that basically translates to, based on 1986 to 2000 levels, 4.7 degrees Fahrenheit to 8.6 degrees Fahrenheit rise over the century, which is just a little bit larger of a range, but still about as high on the high end as the RPC 8.5, according to Dr. Nielsen Gammon. And I'm just kind of curious where you stand vaguely on that.
Yeah, I don't think there's really a lot of disagreement between Dr. Nielsen Gammon and myself. I mean, as a statement of fact, what I said is correct. Of the standard RCP scenarios, the 2.6, 4.5, and 6.0 scenarios all assume some mitigation. The 8.5 does not. Now, that's a statement of fact. You can read the papers on there. I don't think NG would disagree with that. Now, his argument is that that's probably the the RCP 8 is probably a little high, and that it might be a more reasonable business usual scenario might be a little lower than that. And that may be right. My sense is that we actually have no idea what the worst case scenario is. I mean, given all of the creativity that's going into extract hydrocarbons, I find it very hard to believe that our emissions are going to be hydrocarbon limited, that we're only going to be limited by common sense and by radiative physics, not by availability of hydrocarbons. Mm-hmm. So I like NG's analysis. I really don't disagree with it, but I don't think it really contradicts what I said.
And on this estimated climate sensitivity, a lot of these different scientists participating, they're kind of all saying the same thing. Dr. Shakun mentioned, the 1.5 to 4.5 degrees Celsius per doubling. He qualified that with a maybe to emphasize some uncertainty, I assume. But Dr. Scott Denning said, kind of his estimate put it around 3 degrees Celsius per doubling. I mean, is there a lot of daylight between these positions?
I think if you go to a meeting and you talk to scientists out there, you'll find that just about everybody kind of generally falls into the IPCC range, which is 1.5 to 4.5. Mm-hmm. I think that I've been saying for probably 10 years that my personal opinion is 2.7 degrees. Mm-hmm. And actually, as time goes on, I think that's a really solid number. So we'll see where that falls out. That's my personal opinion. I also think that the high end is probably pretty unlikely. Mm-hmm. So I don't see values of 4, 4.5 being likely. But if you sort of ask me if I'm giving a public talk or something, I usually give the IPCC range. I think that's a reasonable range, mm-hmm. And reasonable people have come up with that. So I think that everybody within the range has kind of their own opinions about where they fall, but the IPCC range kind of incorporates everybody. I mean, I think the people that fall out of that range are, they're not doing reasonable science.
But given the unknowns, is there a possibility that, there's been a lot of discussion in the forum on tail risk and what the worst case scenario means, which is the unlikely but still possible worst case scenario. Is that fair to kind of, does that exist? Does a tail risk exist beyond 4C or 4.5C?
Oh, absolutely. I mean, it certainly does. And you could certainly say, even if it's a 1% risk, that motivates action. That's a policy decision. But I certainly think there is a tail risk. Mm-hmm. I just don't see, when I do my research, I don't see a lot of evidence mm-hmm. in favor of that. But, mm-hmm. It could be hiding in there.
Thank you. And kind of given all these different numbers and kind of this range of 2.7C or 3C per doubling of CO2, compared to pre-industrial times, where should the dialogue go, in your opinion, based on this in terms of climate impacts and the question of, how big of a deal is this?
Right. Well, as I have sort of been saying for a couple months, that there's too much discussion about the things we don't know mm-hmm. and not enough discussion about the things we do know. And if you talk about what you don't know, you can really convince yourself that you know nothing. So, going back to my example of tobacco, we don't know how cigarettes cause lung cancer. We don't know how many cigarettes you have to smoke before you get lung cancer. We don't know why some non-smokers get lung cancer and some heavy smokers smoke 4 packs a day and never get lung cancer. You talk about those things, you quickly come to the conclusion, we don't know anything about lung cancer and mm-hmm. smoking. And that's wrong. No. There are lots of things we know. We know that if you smoke, it increases your chance of all sorts of bad things. And similarly, we can sit here and we can argue about how climate change can affect tornadoes, how climate change can affect hurricanes. Mm. And, we don't know. The people, there are people who have strong opinions. They kind of diverge. We just don't know that. But there are things we do know. We know for certain, and we know for certain because they track back to the really fundamental physics. Mm-hmm. Things like we know the temperature is going to go up. We know that extreme heat events are going to go up. We know sea level is going to rise. We know we're going to lose ice on the planet. We know the oceans are going to become more acidic. Mm-hmm. Those are things that it doesn't take complicated physics to tell us. And so you can sit there and you can talk about, we don't understand why Antarctic sea ice is increasing. Okay, I actually haven't looked into that. Maybe we don't know that. Mm-hmm. But that doesn't actually, that doesn't change the things we do know. And, the argument the skeptics advance is that if you can't explain everything, then your theory is worthless. And that's wrong. Mm-hmm. There are lots of things you cannot explain and still have a really robust theory. And again, just go back to smoking, all the things we can't explain, but I'm not going to smoke. I mean, I know it's bad for me. Mm-hmm. I don't have to have a theory about exactly how many cigarettes I smoke before it gets bad. I'm just not going to do it. And similarly, I think, you want to focus on things we know. And if you focus on things we know, you can be really convinced that bad things are afoot.
All right. We'll expand from there and focus on those things and hopefully get some more dialogue on climate impacts before we approach the transition over to the policy discussion and debate. But thank you very much for your time, Dr. Dessler, and hope to hear you again in the forum soon.
Great. Thank you.